Okay, so if we look at this graph, and by the way, this is the function y equals just regular old tangent of x. So a and b are both 1 in this problem, or in this graph. If we look at like the distance from spot to spot where the graph repeats itself, this is pi on this one. And so any of these spots, so if we look at like asymptote to asymptote, like from here to here, that distance is also a pi, a single pi. If we think about that compared to last lesson when we learned about sine and cosine, where we said, okay, well, sine and cosine both have period 2 pi over b. But if we know that here the period of tangent of x is period is pi, and we know that b equals 1, then we know that this 2 pi over b pattern doesn't hold for tangent. And in fact, the formula for the period of the tangent function is pi over b, not not 2 pi over b. So what that really means is the tangent graph kind of repeats twice as quickly as the sines and cosines graphs do, sine and cosine graphs do. So just pay attention to that when you're graphing these tangent graphs. Okay, so the period is pi over b, like I said. What's important to look at, and my favorite way of looking at this is just by looking from asymptote to asymptote. If we look at that, we know that the asymptotes occur every pi over b units. And so if we count that distance, then we can figure out what b is using the kind of same process as we did last time around. The note that I have down here is just about like thinking about the vertical scale or the horizontal scale factor. It's really helpful to think about, okay, where are the asymptotes in this function? Because that's going to help me make my graph look nice and right. When I think about like graphing a tangent function, here are the things that I'm looking for. Normally the tangent function looks like this, right? And so this and kind of repeats over and over again. And that looks more cubic than anything. It's more like this. Sorry about that. So what I want to look at is just this first section that's centered at 0, 0. And that's what I mean when it's centered at 0, 0, because this little spot right here is 0, 0. Okay. Normally our asymptotes are at negative pi over 2 and pi over 2, but we can put this little b in the denominator, which allows us to just kind of scale that asymptote left and right if we need to. So our first two asymptotes are at negative pi over 2b and pi over 2b, and that just helps us find those two spots on the graph. Since the period is pi over b, if we take this spot and then we go another pi over b, then we're going to be over here. If we go another pi over b on this side, we would be over here. And so it's just counting by pi over b's every time. The other thing that I like to look at is just where the tangent function is at 0. And so that would be here and here and here and here. Really, that should be right in the middle between the asymptotes. So these two distances are the same. So this is right in the middle. Generally, I also want you to just pay attention to the shape. Does it look like this, or does it look like this? Okay, is it decreasing or is it increasing at each kind of little part of it? Generally, if you have a that's a big number, you should make it more steep. And if it's a that's a smaller number, then it should look almost more like cubic, like this, like where it's a little bit flatter in the middle. So let's do a little graphing practice. This is just going to allow us to do the practice that we need to with graphing these things and identifying the period and the amplitude, well, not the amplitude, but the stretch factor. So if b equals 1/2, then period is pi over 1/2, which is the same as 2 pi. So every 2 pi units, this thing repeats. Normally, we start the graph at 0, 0, and all of these are going to start at 0, 0. If we repeat every 2 pi, then that means we have to have an asymptote here and an asymptote here. And maybe it's worth plugging in a value. So maybe we would just put in like a pi over 2 to see what we get out. So if we put in tangent of 1/2 pi over 2, that would be equal to tangent of pi over 4, which we know is 1. So the output here is going to be 1. So it's going to look like that. That means that this is going to be over here like this also, and then we know that this function kind of approaches the asymptotes as we go. So it's kind of flat, kind of like that. And so every 2 pi units, it repeats. So there's going to be another asymptote here at 3 pi. And so we would have another spot right here, and another spot like here, and then we would just draw this thing like this. And then maybe we'd do another one like that. Okay, so there's our graph of tangent of 1/2 x. Let's do tangent of 3, or 3 tangent of x. So here our period is pi over 1, because b is 1, so pi. So every pi, this thing repeats, so that means that our asymptotes are going to look like this, because we're centered at 0, 0, and so it's going to have to go, okay, so we're looking for a period that has center right there, so we're going to just count by every pi from there. Like that, okay? If I put in, let's say, pi over 4, again, because I like that spot, 3 tangent of pi over 4 is equal to 3 times 1, which is 3. So if we put in pi over 4, which is right there, we get 3 out. And so this makes sense now. So now we have this kind of very steep tangent function, right, like this. This doesn't have to be perfect or anything. I'm looking for general shape, remember? And so if you can kind of show me the general shape of this thing, I'm going to be pretty happy with your graph. Okay, so your function should look something like this. It should still have a little curve to it, because remember those asymptotes are saying they're approaching the green dotted lines every step, but they're not quite touching them. So I didn't do a super great job with this graph, but again, you can always use Desmos to make sure that you're being a little bit more careful. This one's a little bit more interesting, and so I'm going to zoom in a little bit on it because we have both a B and an A. So A equals 2 and B equals 3. That means that the period is it's pi over 3. And so it repeats, if we center it at 0, 0, this thing is going to repeat every pi over 3 units. And so this distance from the green to the green is pi over 3. And so the green to the green is pi over 3. Notice that I kind of changed the x values so that it would show me more easily where the asymptotes are supposed to be. So I'm just going to do those first couple of periods because I don't think it's going to be super helpful to go too far over from there. This thing is also stretched out because of the 2 there. And so we know that it's going to be pretty tall. And so we can kind of just approximate this thing to say it's going to look like this. Etc. Okay. Notice that really quick, if I put a negative here, then that would just flip everything upside down. And so now we would have a negative. So this would look like this. It's just a little bit of a reminder of something that we saw on Desmos. Really quickly, the other thing I want to do today is I want to do a little bit of solving with equations, just because you're going to be seeing these on the assessment, and I want to make sure that you have a little bit of practice doing these and walkthroughs of me doing them with you. Our solutions are always going to be between 0 and 2 pi, so we're just looking at angles within 1 revolution on the unit circle. So let's solve for theta here. I'm going to subtract 4 first. We get 0 equals -3 cosine of theta. And then let's divide both sides by -3. And we get 0 still equals cosine of theta. And so now I'm looking for, okay, on the unit circle, where are the x values on that unit circle equal to 0? And so my two answers are going to be, this is pi over 2, and this is 3 pi over 2. So my two theta values are theta equals pi over 2 and 3 pi over 2. If I went another circle around, I would get more answers, but remember those aren't within that first rotation on the unit circle. Okay, let's continue. Let's do another one. This is going to feel very similar. We're just going to see this. So now we get -3 tangent of theta equals 3, excuse me. Okay, let's divide both sides by -3. Now it says tangent of theta equals -1. I lost a negative there. There we go. So this is asking where on the unit circle, so let's go to a unit circle here. Where is the tangent equal to -1? And the two spots that I can think of are here and here, because this is going to be 3 pi over 4, and this is going to be 7 pi over 4. So if you remember back to the coordinates here, this would be -√2 over 2, √2 over 2, and this would be √2 over 2, -√2 over 2. Either way, you're going to have this divided by this. And in one example, this is negative, and in the other example, this is negative. So we can choose either one, but we're going to end up with a negative answer either way. This gives us 1. Sorry, it gives us -1 either way. And so the two answers that I can use here are 3 pi over 4 and 7 pi over 4. This is what's called interval notation. This is just another way of writing the same inequality. Theta is between 0 and 2 pi. So we're still looking on that same part of the unit circle, just one rotation around the unit circle. So let's do this. Okay, this one's a little bit tricky, and I want to just kind of expand out my possibilities here, because I noticed that I have some stuff going on with theta inside the tangent function, and so it's important that we just include all of the possibilities. So let's think about the spots on the unit circle where the tangent is √3 over 3. And so when I'm thinking about what's on the unit circle, I'm like, okay, well, I know that √3 over 3 was like 0.577 or something, so it was less than 1. And so what I know then is that the y values need to be less than the x values. And so that means that I'm probably looking at these flat angles like this pi over 6, right? And so I could also be looking at this 5 pi over 6, or this 7 pi over 6, or this 11 pi over 6. But here's the thing, the only ones that actually give me a positive tangent are pi over 6 and 7 pi over 6. What I'm going to do here is I'm just going to include some rotations past 2 pi. And I know this feels a little bit weird because I just said don't do that, but that's going to allow me to include all of the answers where my final answer is between 0 and 2 pi. So we have figured out so far is that all of this stuff inside the tangent, and that means this theta over 3 plus pi over 3, could be all these different options. It could be pi over 6, or 7 pi over 6, or it could be like 13 pi over 6. So what I did here is I took this and I added 2 pi here to get there. And then I could do the same thing. So I could take this and add 2 pi to get to the next one. So that would be, I guess, 19 pi over 6. And let's just do 2 more just in case. So we're going to take this and add 2 pi. So we'd end up with 25 pi over 6. 25 pi over 6. And then also 31 pi over 6. So I'm just giving myself some options because it's possible that I'm working within this range also. So if I now solve for theta, now I have kind of like 6 equations all built into one, so bear with me here, just be careful. I notice that I have divided by 3 on both of these, and so I don't like that, so I'm just going to multiply everything inside by 3. So now I'm going to get a pi over 2, 7 pi over 2, 13 pi over 2, a 19 pi over 2, a 25 pi over 2, 31 pi over 2. So that's all those times 3, and that gives me theta plus pi now on this side. Okay, so if we subtract a pi off, now this one is going to be negative, and so I can cross this one off because I know that that's going to give me something that's negative. If I subtract a pi here, I'm going to end up with 5 pi over 2. If I subtract a pi off of this, I end up with 11 pi over 2. If I subtract off this, I end up with 17 pi over 2. Here's what I notice about all of these. I notice that all of these are bigger than 1. I'm sorry, bigger than 2 pi. And so if they're bigger than 2 pi, that's already telling me that I can't go any further because my numbers are just getting bigger. And so what I end up with is that theta actually has no solutions in this problem. And so that's possible, but it might be worth going back to the graph just to see if I did this right. So what I would do is I would type y equals tangent of theta over 3 plus pi over 3, and then I would do y equals this stuff also. I would put that in Desmos and just see if there are any intersection points between this. Make sure to change your thetas into x's when you do this on Desmos. Okay, so let's go to this one. Sine, remember, on the unit circle is the y values, and so I'm looking for where the y values are 1/2, and so that would give me this spot right here, which would be pi over 6, and then this spot, which would be 5 pi over 6. Okay, so again, I'm going to give myself a couple more rotations, maybe even in the negative angles, just because I noticed that I have a negative going on, and so I might have to multiply by something that's negative, and so I might end up with a negative answer where I think there was going to be a positive one or something like that. Okay, so our two normal angles are pi over 6 and then 5 pi over 6. Notice that if I chose this one, then I would get a negative y value, and that's why I'm not using those ones. Okay, so then if I subtracted a pi over 2 pi from here, I would get negative pi over 6. Just kidding, it'd be negative 7 pi over 6. I would get also negative 11 pi over 6. I'm just thinking, okay, if I start at this angle and I go back, if I go back would be counterclockwise, so I'd be going this way, clockwise I mean. This would give me another spot right here. So if I started here and I went backwards, that would give me negative 7 pi over 6. Okay, negative 11 pi over 6. And then let's just go a little bit further on this side. So we'd end up with 13 pi over 6. And then should be 17 pi over 6. Okay, so this is what negative theta plus 7 pi over 6 is equal to. I guess what I should do now is I should subtract off 7 pi over 6 from all of these parts. Okay, and so now I get negative 18 pi over 6, negative 14 pi over 6, negative pi, negative 2 pi over 6, negative, then I would have 6 pi over 6, and then I'd have, I don't know, I guess 10 pi over 6. So now my concern is like maybe I haven't even gotten all of them, but we'll just kind of see at this point where we're at. So okay, so now this is equal to negative theta. So then if that's what negative theta is, then theta must be just the positive versions of all of these. So this would be 7 pi over 6. This would be 18 pi over 6. This would be 14 pi over 6. This would be pi. This would be Let's reduce this a little bit. So we'd get pi over 3. We'd get pi. Oh, but this one is negative. And then we'd get negative 4 pi over 3. Okay, so now which ones of these are within our range of possibilities? Well, only these two, pi and pi over 3, because these two are negative and these three are greater than 2 pi. So this is kind of why I'm trying to extend my possibilities out a little bit to the left and a little bit to the right, because it's possible that I'm gonna have to cross some off at the end. And so this is important for us to look at. So our two answers are pi and pi over 3, and we are done with the problem.